The Amiga 600 was one of the last computers released by Commodore. It arrived on the market in 1992, shortly before the launch of the Amiga 1200, and only a couple of years before Commodore itself would collapse. When it was first introduced, the reception was somewhat mixed. Many users expected a more powerful successor to the Amiga 500, but instead, Commodore delivered a smaller, redesigned machine that kept much of the same underlying technology. Even so, the Amiga 600 still found a solid audience in several European markets, particularly in the United Kingdom, Spain, and Germany, where it sold reasonably well and became a familiar entry point into the Amiga ecosystem. Personally, even though the Amiga 600 didn't add a huge amount over the Amiga 500 Plus, it's a machine I've always had a soft spot for. One of its most practical improvements is that it was designed with hard drive support in mind. You could install an internal drive, something that wasn't standard on earlier Amigas, and it also included a PCM-CIA slot, which opened the door to additional storage and peripherals. On top of that, I've always liked this design. The computer is compact, and for those of us who collect retro computers, that smaller footprint is actually a big advantage, especially when shelf space starts running out. Just like we did previously with a Commodore 64 that needed a bit of care, in this video, we're going to restore this Amiga 600 and bring it back to its former glory. The goal is simple: give this machine the attention it deserves so it can keep running for another 30 years or more. I've had this Amiga in storage for quite some time now. The case is in excellent condition, there are no cracks, no broken parts, and overall it has held up remarkably well over the years. At first glance, the computer seems to be working properly, although the floppy drive isn't reading any disk. This is actually the first time I've opened it, and the first thing I notice is that there's quite a bit of dirt and dust on the board. The joystick ports also don't appear to be in very good condition, so those will need to be replaced as well. The first thing I'm going to do is clean the motherboard, but before that, I'll need to remove a few components, starting with the RF modulator housing. Once the board is ready, I'll wash it using distilled water. This helps ensure that no mineral residues from tap water remain on the board, which could eventually lead to corrosion. Using a soft brush, and preferably without any cleaning products, I gently scrub the board. The idea is to remove the dirt without applying too much pressure, but still cleaning it thoroughly. If it ever becomes necessary to use a cleaning product to remove stubborn grime, it's important to rinse the board very well afterwards, making sure that no residues are left behind that could damage the components over time. Finally, I make sure the board is completely dry using a hot air gun, paying special attention to any moisture that might remain trapped under the chips. After that, I'll leave the board to dry for at least 24 hours, just to make sure all remaining humidity has completely evaporated. And here's the final result. The board is now clean and looking great. The next step to keep this Amiga in good long-term health will be replacing the capacitors. For the capacitor replacement, I recommend using high-quality components. In some specialized stores, you can even find ready-made kits that include all the capacitors needed for this model. Since I've already removed several components while cleaning the board, I'll take the opportunity to protect the nearby components with Kapton tape. This will make it much easier to work on the transistors safely. It's generally a good idea to replace the capacitors in this model of Amiga, because over time they can start to leak electrolyte, which may eventually cause serious damage to the motherboard. Fortunately, it's not a particularly complicated job. You just need to work carefully to avoid damaging the pads while removing the old capacitors. I'll also take the opportunity to add some fresh solder to the pads to finish the job properly. Finally, the last thing left to do is replace the joystick and mouse DB9 ports. When installing the new connectors, it's important to make sure that the pins that connect to the motherboard are positioned on the bottom side of the port. Before soldering the replacements in place, I'll also clean away the old solder and double-check that the pads and traces are still in good condition. And with this simple bit of maintenance, this Amiga 600 should be ready to keep running for another 30 years. The Amiga boots perfectly and produces a clear and sharp image through the RGB video output, which is the connection I generally recommend using. However, the composite video output doesn't look right. All the symptoms point to a problem in the Amiga video encoder, a component that can sometimes fail with age, or possibly one of the filter components the signal depends on. Regardless of which component is actually failing, my first approach will be to replace the original video encoder with a more modern one. There are two good reasons for doing this. First, it can improve the overall composite video quality, and second, the newer encoder integrates some of the functions that were originally handled by external components, which simplifies part of the Amiga's composite video circuit. As a result, we can eliminate several components from the original circuit, making the video path a bit cleaner and easier to maintain. This modification is a bit more involved than simply replacing the capacitors, and it can be tricky if you don't already have some experience working with a hot air station and a soldering iron. In my case, I happen to have a few Sony CX-A2075M video encoders as spare parts. However, there are more modern and easier to find alternatives available today. Just keep in mind that none of these chips are direct drop-in replacements, so you'll need to pay close attention to the pinout and wiring before installing one. With this particular chip, we'll need to cut pins 8 and 9 so they don't get in the way, since they won't be used in this installation. We'll also need to bridge the corresponding pads on the motherboard. On the Amiga board, those pads are part of the audio input and output path, so by bridging them we simply pass the audio straight through. In many Amiga modding forums, users have reported that it's a good idea to enable the chip's internal trap filter, as it can help reduce cross-color in the composite signal. Looking at the chip's documentation, enabling the internal trap filter in PAL mode requires feeding the pin through a 2.61 kilo-ohm resistor with 1% tolerance. To do this, we'll use the signal available on pad 12 to provide the required connection for the internal trap filter. The 2.61 kilo-ohm resistor isn't a very common value, so instead, I'll combine two resistors in series, a 2.2 kilo-ohm and a 470 ohm. This won't give us the exact value, but that's perfectly fine. Even if we end up a little further from the target resistance, the only thing that changes slightly is the strength of the color mixing effect, so it isn't especially critical. Some parts of the Amiga's original video circuit are no longer needed, since those functions are already integrated into the new encoder chip. To disable these sections of the circuit, we'll need to remove a few components located on the underside of the motherboard close to the video encoder. It looks like the issue is finally fixed. The image quality over composite video is still lower than what you get from the RGB output, but that slightly imperfect look is actually part of the charm. In fact, that's exactly the kind of nostalgic video signal I really love. The Amiga 600 includes a 44-pin IDE controller built directly into the motherboard, which means we can easily connect storage devices using a simple adapter. With the right adapter, you can use a compact flash card, an SD card, or even a small IDE hard drive connected straight to that port. This makes it very convenient to install Workbench. The fastest way to install Workbench is by using the UAE emulator, mounting the compact flash card directly as a UAE device. Optionally, instead of using the system's default file system, we can install Professional File System 3, which is generally more optimized and faster on Amiga systems. To do that, I'll mount the LHA archive containing the file system driver as a PC1 device, so it can be accessed during the installation process. Then, using the hard disk utility included with the Workbench installation disks, we can prepare the drive and get it ready for installing the operating system. Before configuring the drive, we first need to update the device name. To do this, select the Hard Drive Toolbox icon and open the Information option. Then locate the SCSI device name field and replace it with the device name that UAE assigned when we mounted the disk. Now we can configure the drive. First, we open the utility, select the disk we mounted, and go into the configuration settings. In my case, since I've already done this before, I'll simply edit the configuration that was previously saved. But if this is your first time, you'll need to create a new drive definition. By clicking Read Configuration, the tool will detect the drive's parameters automatically. After confirming that everything looks correct, we can save the configuration and move on to creating the partitions. Normally, you would create two partitions, one for the system and another for programs and games. In my case, however, I'm going to create a single partition that uses the entire drive. So I'll remove the empty space and define one partition that covers the whole disk. If I were using the default fast file system, the job would already be done. I could simply accept the changes and continue with the installation. But since I'm going to use a different file system, I first need to load the driver using the Add Update button. Since I mounted the driver as the PC1 device, I'll simply enter the full path to it in the dialog window. When the system asks for the DOS type, we just need to enter the values exactly as shown here, and then press Enter. Now we can assign the file system to the partition. Open Advanced Options, click Change, and select the PFS3 file system. To avoid possible compatibility issues with compact flash cards or adapters, we'll also change the max transfer value to 1FE00 and press Enter. With that done, everything is ready. We just need to apply the changes to the drive by clicking Save Changes to Drive. After a reboot, the disk will be fully prepared for installing Workbench. Once the computer has restarted, we can unmount the device containing the driver, if it's still mounted, and then format the new hard drive to initialize it. The Workbench installation will take a little while, but if we configure the emulator to run at maximum speed, the process will be much faster than installing it directly on the Amiga 600. Finally, the only thing left is to install a few essential tools, such archive extractors or WHD load, which allows us to run many games directly from the hard drive. I won't go into the installation of these tools in this video, but if you'd like to see a separate tutorial, let me know in the comments. One thing that can sometimes happen with WHD load is that the quit key may be mapped to a key that doesn't exist on the Amiga 600 keyboard. Because this Amiga uses a more compact keyboard, it doesn't include a numeric keypad, and a few keys found on larger Amiga models are missing, such as the print screen key, which is often used as the default quit key in some installs. We can easily change the quit key by adding a line to the game's icon configuration. To do this, right-click the icon and open the information window. In the Tool Types section, add a new line with quit key, followed by the key code of the key you want to assign. For example, you can set it to 59 in hexadecimal, which corresponds to the F10 key. And that's it. Our Amiga 600 is now fully set up. All that's left is to load it up with backups of our original games and start enjoying them on this fantastic little machine. Even though the Amiga 600 had a somewhat lukewarm reception when it was first released, it has always remained one of my favorite computers. The floppy drive in this Amiga isn't working, which is actually quite common. These drives usually saw a lot of use during their lifetime, so failures are not unusual. Instead of trying to repair it, I'm going to replace it with a newer drive, which has most likely seen much less use, since many of them originally came from systems that relied primarily on hard drives. In this case, I'll be using a Samsung drive, although it will require a few modifications before it can work properly in the Amiga. Adapting this drive is actually very straightforward. We just need to move the DC jumper to the ready position, create a connection between pin 2 of the connector and DC, and finally set the drive ID to unit 0. This drive looks like it's been in storage for quite a long time, so it definitely needs a bit of cleaning. I'll pay special attention to the heads, gently cleaning them with a little isopropyl alcohol, being careful not to damage or misalign them. This drive has the motor spinning hub exposed on the underside, which means it could potentially rub against the data cable. On the Amiga 500, the floppy drive is mounted on a small metal bracket, which keeps some distance between the drive and the cables. But in the Amiga 600, that bracket isn't present. So to avoid the cable touching the spinning hub, I'll place a thin plastic sheet underneath the drive as a simple protective barrier. Finally, I tried 3D printing several eject buttons that I found online. Unfortunately, most of them were designed for the Amiga 500, and none of them fit properly in the Amiga 600 case. So in the end, I decided to design my own eject button, and this one fits perfectly. If you'd like to use it yourself, you can download the model from my GitHub repository. The case of this Amiga is in very good condition. It's slightly yellowed compared to my other Amiga 600, but that's something that can be improved with a bit of sunlight treatment. At this point, the only thing it really needs is a thorough clean. I'll start with the keyboard. Along with giving it a good clean, I'm also going to replace the membrane since some of the keys don't seem to be responding properly. So, let's begin with the disassembly. To properly clean the keyboard and replace the membrane, I'll also need to fully disassemble the keyboard assembly. When it comes to replacing the membrane, it's important to know that there are two different types, which can usually be identified by their color. In this case, the green membrane corresponds to the Mitsumi version. Once the keyboard assembly has been cleaned under running water, I'll make sure to dry it thoroughly to prevent any corrosion on the metal parts, such as the key springs or the base. After that, I'll clean each key individually, making sure everything is spotless and bringing this Amiga back to like new condition. With everything reassembled, all that's left now is to sit back and enjoy this fantastic machine, one of my all-time favorite computers. If you enjoyed this video, don't forget to leave a like and subscribe to the channel if you're into this kind of content. I upload a new video every month, so stay tuned. Thank you so much for watching all the way to the end, and I'll see you in the comments. See you in the next one.